Hello student friends, welcome to Let Us Learn BEE. Today the session starts with Parallel Adder CUM Subtractor for JNTU, Anna University and VTU syllabus. So before entering into the Parallel Adder CUM Subtractor, we have to know about the XOR gate. Already the XOR gate and then NOR gate difference is given in the previous video. That link is given in the description box. So here we are going to discuss the XOR gate. So XOR gate, it is an odd one detector. If two inputs are there, in the two inputs, if any one of the input value is 1, then the output will be 1. Say for example, see A is 0 and B is 1. So at the time we are getting the output as a 1. Similarly, A is 1 and B is 0. So in this two inputs values, here we are having 1. That is only one is present. That is odd one is present in the input. So we are getting the output as a 1. Rest all the values are 0. So this OR gate, XOR gate is called as a odd one detector. This it shows the symbol of the XOR gate with two input. Parallel adder subtractor. The addition and subtraction operation can be combined into one circuit with one common binary adder. This is done by including an exclusive OR gate or XOR gate with each full adder. Already we discussed that full adder in the previous session. That link also given in the description box. You can have a glance on this. Here the mode input M, that is very important. The M which controls the operation. It is depending on the M whether the parallel adder or parallel subtractor it will act as. So when M is equal to 0, that is mode is equal to 0, the circuit is adder. When M is equal to 1, the circuit it becomes a subtractor. So following that, now we are going to see the 4-bit adder CUM subtractor circuit with a logic diagram. This diagram it shows the 4-bit adder and subtractor circuit. So here we are having totally 8 inputs are there. A0, A1, A2, A3. Then B0, B1, B2, B3. And M is the mode. C0 is the carry in. C1 is a carry in for the next full adder. FA1 is the full adder 1, full adder 2, full adder 3 and full adder 4. So with this diagram we are going to discuss with one example. Now let us discuss the 4-bit binary adder with an example. So A is equal to 1010. For this the decimal value is 10 and B is equal to 0100. The decimal value is 4 and then here the place it's given B0, B1, B2, B3, A0, A1, A2, A3 is given. For this binary adder M value is equal to 0, that is mode is equal to 0. So we are considering M is equal to 0. So M is equal to 0 means carry in is also 0. So as per the given question, A0 is equal to 0 and A1 is equal to 1, A2 is equal to 0, A3 is equal to 1. Similarly, B value is also given. So B0 is equal to 0 and B1 is equal to 0 and B2 is equal to 1, B3 is equal to 0. M value is given as a common to all as a 0. So we have to put M value as 0. Now already we discussed that XOR gate. XOR gate the output will be high when odd one is there. That is called as an odd one detector. So here both the inputs are 0. So obviously we'll get the value of 0. So here also 0. So we'll get 0. So here 1 and 0 is there. If 1 and 0 is there, the output will be high. That is 1. So in this B3 we are getting both the inputs are 0. So the output is 0. Now we have to find the S0. So S0 is equal to A0 plus B0 plus C0. So A0 plus B0 plus C0. So A0 value is 0 and B0 value is 0 and C0 value is 0. So if we add this, S0 is equal to 0 and then carry is equal to 0. So here we'll get the carry is also 0. So next we are going to find the S1. So S1 is equal to A1 plus B1 plus C1. So A1 is equal to 1 and B1 is equal to 0 and C1 is equal to 0. So if we add this, we will get 1. Therefore, S1 is equal to 1 and then carry is 0. So we got S1 is equal to 1 and then carry is 0. Now in the third full adder, the S2 is equal to A2 plus B2 plus B2 plus C2. So here A2 value is 0 and then B2 value is 1 and C2 value is 0. So here also we will get the output as a 1. Therefore S2 is equal to 1 and carry is also 0. So next we are going to find the S3. So S3 is equal to A3 plus B3 plus C3. So A3 value is 1 and B3 value is 0 and then C3 value is 0. So here we will get S3 is equal to 1 and then carry is 0. So carry we will get 0 here and then S3 value is 1. So finally we got the output sum that is equal to S3, S2, S1, S0. So we are going to write in that place. So S3 is 1 and S2 is 1 and S1 is 1, S0 is 0. So for this, if you find the decimal value for 8421 4 bit, so this place is 8, this place is 4 and this place is 2. So 8 plus 4 plus 2 we will get 14. So let us cross check this. So A decimal value is 10 and B decimal value is 4. So if you add this 10 plus 4 we are getting 14. So thus we obtain the 4-bit binary adder. Next we will discuss the 4-bit binary subtractor with the value of m is equal to 1. So now we are going to discuss this 4-bit binary subtractor. The value of m is 1 and then the same example, A value is 1 0 1 0 and then B value is 0 1 0 0 and then decimal value also given. The main change in this is the difference between the 4-bit binary adder and subtractor. In the subtractor the m value should be 1. So here we are taking the m value, that the mode value is 1. Therefore the input carry is also 1. So C0 is equal to 1. So as per the given question, A0 value is 0 and A1 value is 1, A2 value is 0 and A3 value is 1. Similarly now B0 value is 0 and then B1 value is 0, B2 value is 1, B3 value is 0, M value is 1. So we have to put common for all the XOR gate. So already we discussed that XOR gate is an odd one detector. So here only one is there. So we will get the output as a 1. Here also we are having 1 and 0. So the output is high. Here we are having even ones. So the output is 0. So here we are having odd 1. So the output is 1, that is high. Now we are going to find the value of S0. So S0 is equal to A0 plus B0 plus C0. So A0 value is 0 plus B0 is 1 plus C0 is 1. So if you add this 1 plus 0 we'll get 1. Again 1 plus 1 is 0. And then carry will be 1. So here we will get the carry as a 1. So here S0 value is 0. Okay. So now next to that we are going to find the value of S1. So S1 is equal to A1 plus B1 plus C1. So A1 value is 1 and then B1 value is 1, C1 value is also 1. So if you add this we will get sum is equal to 1 and carry is also 1. So S1 value we are getting 1 and then carry is also we are getting 1. So now we are going to find the value of S2. S2 is equal to A2 plus B2 plus C2. So A2 value is 0 and then B2 value is 0, C2 value is 1. So if you add this we will get S2 is equal to 1. So carry is 0. Carry will get 0, that is C3 will get 0. Now we are going to find the S3. S3 is equal to A3 plus B3 plus C3. So A3 value is 1 and B3 value is 1 and C3 value is 0. So 1 plus 1 will get 0 and then carry will be 1. So here we will get the carry. Now sum is equal to S3 plus S3, S2, S1, S0. So in the place of S3 we got 0. In the place of S2 we got 1. In the place of S1 we got 1. In the place of S0 we got 0. So finally, if you find this decimal value for this according to 8421, that is 4-bit. So here 4 and 2 is there. So this value, the decimal value of this is 6. So we can cross check. The decimal value of A is 10 and decimal value of B is 4. If you subtract 10 minus 4, we will get 6. So the obtained answer is correct. So far we discussed the 4-bit binary adder when value of mode is equal to 0, and then 4-bit binary subtractor when the value of mode m is equal to 1. So this is about the parallel adder cum subtractor. In a single circuit with use of the XOR gate, we are find out the parallel subtraction and then addition. So next, that's it for today. Thank you for watching this video.